The third one is a very interesting device, which is actually fiber optic crack sensor. This sensor is used to locate the cracks, essentially the flexural cracks in beams and slabs of buildings. Optical fibers are integrated into a textile net structure, which is designed to transfer elongation due to cracks developed on the structure to the optical fibers. Since the failure stress of optical glass fibers is relatively low, integrated optical fiber will break even under the formation of small cracks. Then, with the help of optical time domain recorder, cracks are located. Integration of the optical fiber into the textile structure can be done in two ways. You can either stitch the fiber to the structure, or you can do knitting of the fiber to the structure. The principal objective of fabrication is to minimize losses due to bends, and therefore, to obtain the best bonding. Alternatively, optical fibers are also used to monitor shape of the crack tip in concrete members. In this case, the principle followed behind the application is that network of optical fibers break when cracks propagate in the members intersect these fibers. They are very helpful to locate the cracks. Alternatively, optical fibers can be laid in a zigzag manner at the bottom of the concrete beam to detect the flexural cracks in the beam. When the cracks open in the member, optical fibers intersecting the crack at an angle other than 90 had to bend, okay? And this sudden bending of the fiber causes optical power loss, indicating location of the cracks. This method is very highly suitable to detect cracks of smaller size, let us say about 0.1 millimeters. Optical fibers should be laid inside concrete such that these fibers should be free to slide inside concrete. Alternatively, there are fiber optic sensors which are also used to detect cracks in composites. They are otherwise called as self monitoring technique, additional reading can be seen from Let us see how these kind of sensors work. These fiber optic sensors contain an electric conductive phase such as carbon fiber and the conductive power in cement or polymetric mix. These sensors can monitor their own strain, damage and temperature variation effects. By the embedded or reinforced carbon fibers, which acts as self monitoring sensors. Okay. Let us quickly see what are the different composite which has different electric conducive material and what is the matrix. The most popular is carbon fiber reinforcement, which is reinforcement concrete, which is CFRC. It contains short carbon fiber. Short in terms, the length is less than 10 millimeters and the volume is about 0.5 volumetric percentage in the mixture. The matrix used is cement, mortar, concrete including admixtures. The second kind of reinforced composite is carbon fiber reinforced polymer CFRP, which again has short carbon fibers. The length is less than 10 millimeter. Sometimes it is also fabricated with continuous carbon fibers. The matrix agent used is resin and curing agent. The third type of fiber reinforced composite, which is self monitoring, is carbon fiber, glass fiber, reinforced polymer, which is carbon fiber, glass fiber, reinforced polymer, which actually has continuous carbon fiber. The mixture is having about less than 0.5% volume percentage. Resin and the curing agent are used as a matrix. The fourth one uses a carbon powder dispersed in glass fiber reinforced plastic. This has got a graphite carbon powder. the mixture is about 0.15% volume and the average particle diameter used is about 5 microns. The matrix used is resin and the curing agent. So, friends, these are different kinds of composites which act as self monitoring sensors, but more interestingly they are all examined only in the lab scale. A real time application is yet to happen in sense of its large surface areas. The next kind of sensor we have is magnetostrictive sensors. Ferromagnetic materials when placed in magnetic field are mechanically deformed. This property is called magnetostrictive effect. In the reverse, magnetic induction of material changes when the material is mechanically deformed. This is of course called inverse magnetostrictive effect. These sensors are useful to detect voids in concrete filled steel pipes. These sensors could generate guided waves of different modes propagating along the length of the pipe. These waves are then sensitized to the defects in the pipe and they detect the damage. The recede wave amplitude decreases with the increase in voids and inclusions, and that indication is useful to detect damage in, let us say, concrete filled pipes. One of the major disadvantage of this sensor is that the ultrasonic energy emitted is very low in strength. Of course, this can be improved by combining this sensor with other piezoelectric sensors. So, friends, in this lecture we spoke about fiber optic sensors, their classification, about 4 to 5 types of these sensors used for moisture ingression, used for crack detection, used also in case of concrete filled pipelines, which are all of unique applications and very useful. Some of them are on lab scale, researchers have examined and tested them, but a real time application in terms of large projects has yet to happen. In the next lecture we will talk about smart sensing, how sensors can become smart to do health monitoring for structures and their applications in unique structures like offshore structures. Thank you very much. See you in the next lecture. Bye.